Hello, everyone, and welcome to Learning Robots, episode 3. So, let's get straight into it. Now that we finished the Clawbot, we have to start something new. So, the other day, I was watching The Amazing Spider-Man 1, Andrew Garfield, my goat. And I was watching the scene where Uncle Ben was coming into Peter's room when he was going through the dad's documents, and I noticed Peter Parker had an automatic door lock that he could control from his computer. Now, that idea itself is pretty cool, but if I make that myself, I mean, there's so many things out there that can already do that, like the automatic door locks with the key codes. I have one of those, and all of that. So, I wanted to throw my own spin on it. I had two ideas, but I think for this first video, we're just going to design the automatic deadbolt itself with the key, and then we'll have a second and third doing other things. So my first idea, besides making the deadbolt, was knocking. So like when you're a little passcode or you had to do a special knock. So I think I wanted to code it to where if you do a specific knock on my door, like it would open. And another thing I wanted to do is I have something real quick. Is this thing right here. A couple years ago, I bought this thing. It came with my Amazon Alexa show. And it is a plug that you can tell Alexa to turn on and off. Like, hey, Alexa, turn on blah, blah, blah computer. Alexa, turn off. Alexa, turn on. So I was thinking, what if I go in here and I solder out the part that connects to Alexa, and boom, I connect it to my thing, and I can say, Alexa, lock door. Alexa, unlock door. So that's going to be a little bit harder. That's why I'm going to save it for last. Because I literally just learned how to solder from my dad, and I'm not going to go straight into whatever super high tech that companies like Alexa and so on have. So let's get into designing that door lock. All right, because I'm trying to stop people from getting in, I can't make this one out of plastic. So I went to Home Depot and I picked up some items. So I have these metal brackets. These metal brackets right here. And here's what I was thinking to do with these metal brackets. So I bend them with this thing I have in the garage, and I get it big enough to put a metal bar in between. And then I can print like a spacer so it's level with the door here. So I measure with the caliper and I just print a spacer. I bend the thing, and I bend the other thing. And then I put a wheel on this stepper motor here that kind of uses the wheel to slide in and out a metal bar. This said metal bar. It's a bit long and a bit thick right now. So I'm going to obviously get the dimensions first. Then I'm going to cut it like probably in half. And then as long as I need for I guess it has to be at least that long so it can slide in and out comfortably. And I'll have the brackets fit around it. And then the rest can be PCB plastic. So since this was something that wanted to be portable, I wanted to use a smaller microcontroller and something not as big as my Arduino because I want this to be nice and compact, like right here. So I did buy an Arduino Nano, this one right here. I tried soldering it, or my dad helped me on and it honestly turned out really bad because me nor him are soldering pros. So we think we ruined the board. And I had a second one, and I tried doing it before I even soldered it, and it still wouldn't work. So I couldn't really figure out how these things work. So I got a couple of these bad boys. I heard some good things about them. These are just the ESPs, like the Chinese versions. These are like $3 to $4. So even if these fail, it's a lot better than the $10 per. And I've seen a lot of good things about these. And it's pre-pinned, so I didn't have to solder anything. So let's start designing the door before we do anything else, now that we know our game plan. Alright, so that metal bar I was talking about, this is it. This is an aluminum bar that my dad just had in a bucket in the garage. So I'm going to use this because use what you have, you know? So I think I'm gonna cut about like this much off for him. I think that should be fine, or maybe less. Honestly, I don't need that much. And now vision this. I bend I bend these to go around, right? And then they screw on the door. One for each side. Then what I have here, these rubber wheels. These rubber wheels, $6 for 4 of them. They're at my local Home Depot. Oh, yeah, they're at my local Home Depot. So I picked these up. I take out the wheels. I only need one stepper motor because it can do all the work. I use this stepper motor or another one that doesn't have something on it, and it goes up on here. But I'll see if the stepper motor alone can do it, and then I have a wheel on the bottom. That will save more space. But I feel like that's a pretty good design idea. So I'm gonna get those wheels. But before I make anything or cut this or do anything like that, because my dad kind of wants the rest of this bar, he said not to use a lot. I'm gonna play around with my stepper because I have my breadboard. This is what I'm gonna use to control it. Then in here, I have, I think these are DR DDRs, like 887 or something. Not 100% sure. I don't remember. But this is what controls the stepper. So I'm gonna figure that out. Then I'll start cutting because I don't want to, cut what I. Yeah, I want to get the right measurement, and I'll probably load it up in CAD first. So you're gonna cut to when I'm at Home Depot. All right, I got what I needed from Home Depot. This right here. So it's a little bit different than planned. I did want to get those plastic white wheels, but they were a bit bigger than I wanted them. And these were really nice and small. They're like very small. Here's them compared to my pinky. So I feel like I can make this more compact. Now here's the problem. This is plastic. With the problem comes a really easy solution. See, electrical tape does have some good rubbery friction. So I take the wheel off and I cover it in electrical tape on the edges so it has more friction and can move the bar easier. That's my solution. So now that we have the idea down, the parts, the sizes that I need, I could load all this into CAD because I know the sizes now. That means time to get to work. Since I don't know how to use stepper motors yet, I'm going to give you guys this little montage where I just figure it out by myself with some maybe YouTube videos or just playing around with it. That's kind of how I learn this stuff. I just like play around with the thing itself and like learn as I go. So let's get to it. I successfully coded with the ESP32, so now I can get it working. So now we try and do it like we do it with the Arduino, and we get it connected to this driver controller. All right, editor me here. Here I am on the screen. As you can see here, I kind of had like an aha moment. I'm like, I was watching some videos to try and understand why what I had wasn't working because I had some code that theoretically should have just done a little spin on the motor over and over again. I'm like, why isn't it working? I see, oh, it's like 12 to 24 volts. So my genius self, sarcastically, grabs a 3D printer power source, which is like 112 to 220 volts or something like that. And I just decided to start playing around with it to see if I can somehow get it low enough to power um
my one motor when this thing is supposed to power a computer, a motor, a heater, another heater, and multiple motors. So, you know, so you're going to see some fantastic choices in life. So here we're witnessing genius action number one, causing a breaker shortage. I plugged this in, and I think like either the ground or neutral was just like directly connected to each other, and I shorted my breaker. Look how smart I look in this clip. Thinking I had it all figured out, I turned on my breaker and came back for round two. And let's see how that went. Not as well as the first time. Kidding, bro. I shorted it again, and just look at my face here, man. Beautiful. But luckily for me, the third time was the charm, because around the third time, I actually got the power source plugged in. Now, this might sound like a good thing, but you're going to see why it's not. Well, now that I have the power source all hooked up and ready, I'm going to connect it to the speed controller just to see if the voltage is enough. Now, at the time it read at 19 volts on my multimeter, so I was like, okay, it should work, but I really didn't account for like the amount of current this thing had behind it. But at the moment, I had the plug itself figured out, but not how to get the power through the power source itself. So right now I'm figuring out like the setting up the wires and all that, and just getting the gist of it. I don't think I had the connecting wires from the plug into the power source right, and so I eventually fixed that. So you'll see that here. So the power source kept on failing me, so I opened it up to see if something was wrong or just look at it inside. Um, and this wasn't a very smart idea on my part. Yeah, I just got shocked. I don't know how many volts it was, but I couldn't feel my hand for like a minute or two. But it was really bad. I ended up just scrapping playing with this power source like right after this happened. It was so bad, and I felt stuff in like my chest. Don't open a power source. And if you're wondering, it was switched off. It was switched off. I am not that dumb. But before I gave up on it because it hurt me a little, I put on these super rubber gloves and I was going to try again. But in the end, I just ended up scrapping the whole 3D power supply idea because number one, it hurt me a lot. And number two, I really couldn't figure out how to get this thing connected to my motor driver without it absolutely blowing up the wires with the pure current it had. So I decided to move to a plan B. I don't know how stupid this is, but I'm gonna solder together a bunch of batteries. So the whole soldering thing wasn't exactly working out for me here. So I decided to pivot my strategy and instead move to taping the batteries together. Because I did this for like a little YouTube short I made and it low key worked pretty well. So I basically just put a lot of tension on the tape and taped the batteries together. The electrical tape works pretty well for a lot of things. So I made three battery AA cells, if I could call them that. As you can see, the three cells, they're like long columns. So now to connect the cells, I came up with the idea of cutting off some resistor ends. And then I was going to try and solder it to it, but that didn't work. So then I ended up, again, taping it, and that worked. So I guess tape's just like cracked for batteries. So yeah. 15 volts flowing with my custom battery, but it's not working for some reason. I really can't get this thing to work right here. So I'm gonna try going through a bunch of things off camera, see if I can get it to go.
Alright guys, it has been 11 days since that last video. I did have a good vacation, but I can tell you guys, the entire time, I was thinking about this. So, um, all the stuff I did with the power sources, I, I think it's safe to say most of that was useless. Because, I realized that I have, this bad boy right here. And this is a stepper motor that is already plugged in and easy to code with the Arduino, and it's a lot smaller than my other stepper motors. It is going to be slower, but speed's not exactly an objective on this thing, and it's aluminium, so it's not going to be that heavy to move. So I think it could move it. So I think what I should really do is create a design with this. It does the job, and I think the final like door locking mechanism would be way too big if I have that super fat stepper motor and I have to have like a bunch of batteries on it. I think this would be a lot less powered, and I wouldn't even have to have like a circuit board or anything, because what it could do is just plugs into the ground, plugs into the hot, and does its work from there. So I think what I'm going to do is I'm going to start designing on CAD. All right, I just did some measuring and some thinking. And what I think I'm gonna do is I'm gonna do 0.75 inch length. I'm gonna do, oh no, 0.75 inch width. Then I'm gonna do a 4 inch length because I measured between the door, and I think 4 might be a bit big, but I want to start bigger and just see how that works. And if not, I just trim it down a little. And I'll just keep the thickness. So I'm gonna make this bar in CAD and.
All right, this part's pretty straightforward. I'm just going to make the 4 inches by 0.25 inch bar that will, simulate the bar that goes in between my door. So let me just speed through that real quick. Well, so I just thought of something. I actually have to take the wheels out of this thing right now and measure them so I can put them into CAD. So I guess let's go do that. Now, if you're wondering how I'm going to get the wheels outside of the dolly, it's pretty simple. I'm going to take my trusty, dusty Dremel and I'm going to put on the cutter attachment, at least for metal, is what I know because my dad helped me out and show me. And I'm going to use it to cut off the wheel. And I'll keep it in this clamp right here and then use the Dremel to take it out. Pretty straightforward, pretty cutthroat. But I didn't go about this the smartest way. I'll show you guys. All I'm saying here is that I'm going to put this little centerpiece on the Dremel, but I did some yapping, so let's just not do that. Now I'm going to show you this next clip. I still have no clue what happened, but it hurt like hell, so watch closely and tell me what happened. I had no clue what I did wrong in this moment exactly. I mean, I might have just like not tightened something enough, but it was scary as heck. So just let me know what you guys think. But anyways, let's just move back on with the project. Now that I got done with getting those wheels off, I just wanted to put that Dremel away and move on because,
All I gotta say is thank goodness for my glasses. If I didn't have those glasses on, I don't know if you fully saw it in the clip or not, because I didn't really look back at the clip. I just finished cleaning up and all that. The Dremel broke off. The thing went flying and it hit right here. It scared me so bad. So that's why after you saw that, I took it off with the hammer and the clamps, because I was like, I ain't touching that Dremel again. So I got it off. I got the 2 wheels. I don't need 3 wheels. I'm not gonna do that right now because of the Dremel. But if I do need the third one, I'll do it again. But now that I got the wheels, let's see how they line up. Looks a bit big, but what can you do? Maybe I'll just 3D print a wheel. I mean, that wouldn't be the worst idea ever. I mean, for this right here, I think I might use some sort of resin or something to attach them to each other, because I don't know how else I'll get these 2 together. I'm gonna search up on YouTube for some ideas and some AI. So I think I'm gonna clean up, get a little energy drink, and do that. Cue time lapse. So I watched a video or 2, like I think 3 total actually, and I saw like there's the last one I watched right there. He puts a collar that goes on the shaft, and then a screw tightens in, pushing it. So basically, what I did in Vex Robotics, whenever I put something on an axle, I had a collar. So I can either buy the collar, $10, $5, whatever, or I could drill a hole into the side of it for a screw, and just put a screw in, like through the side of the wheel. Like drill a hole in one of the sides, and then just have a screw that sits in there and tighten. So number one, I don't waste room on a collar, because if I put a collar on there, it'd stick out like this. I don't really want that. I would like for it to sit flush. And two, I wouldn't have to waste any money. This is for me to learn, not to pre-buy stuff. So I'm gonna do option 2 and go to Home Depot, buy a short screw. I have screws here. I want to see if those work.
So the screws were the right size, so now it's time to drill those holes and, put those screws in. Let's get to work.
Alright, so pretty simple if you guys were watching. Basically, I just kind of made my own collar wheel. So it goes through and the screw will sit inside of here when fully screwed in, and it won't interrupt the roll, and it'll press down on this axle. But it is kind of wobbly right now, so I feel like I could benefit from a spacer. So I'm gonna print a plastic spacer with my 3D printer. Benefits, right? So let's do it.
Basically, here we have it. Pretty simple. Radius of everything. It's just a spacer. So we'll export it. 3MF. That's weird. Alright, slice plate. Print plate. Let's make it black. Alright. Now I'm gonna send you to the printer. Try some more cool shots,
Looks like it worked great. Let's pull it out and see. Alright, as you can see, not the straightest wheel in the world, but I don't think it's a big deal. It's just going to be rotating, doesn't come off, and it's just going to be rotating, as long as the other part of the wheel just pushes it on, I think it'll be okay, but it's not very well aligned. If I had a drill press, it would be a lot better, but... Alright, so the whole wheel thing, yeah, it's cool, but it's really big, and my wheel isn't straight, and I can't use a smaller screw because the wheel's really big. So, and it's not even a rubber wheel, because the whole reason I was trying to do the wheels is because rubber, more friction. But then I looked at Home Depot and I looked everywhere, and I couldn't find any like wheels that I wanted that were that size. So what I can do is I'm just gonna 3D design and print a wheel, because I'm gonna put electrical tape around the edge anyways. But then I kept on thinking, I was like, yo, doesn't bamboo make squishy like 3D filament? Like 3D filament that literally compress in. So I was thinking that I buy some of that filament, and I didn't really tell you guys this, but I was gonna use a spring mechanism to push the wheels together so there's friction. So if I get a squishy filament and have the springs, it should be able to, like, the filament will squish and grab the bar really well. So I think I'm gonna 3D design a wheel for that purpose, and I'll be able to perfectly put an area to fit a screw in. So I'm gonna do that. Okay, so this one doesn't come off no matter how hard I pull. Well, like if I unscrew it, it does. But the new one comes off pretty easily. I think it's because of the screw. The screw on the new one has a lot less threading than this one. So I might need to go pick up new hardware for this.
Alright, so here's a little solution I came up with. So what was happening was the screw I had before, its threads were like kind of weird, so it didn't really
work all the way. So this was my wheel before. For space purposes, I like the size of the other wheel, so I'm gonna keep the spring-loaded wheel the same size, but I'm gonna make the other wheel bigger so that other screw that I showed you guys before that went in the black wheel will be big enough to fit in this. And that one had proper threading, so I think it should be okay. Alright, so I'm gonna load up my new design and get that printed, so let's do that real quick. But I think it should be good, so I'll come back to you guys when it's all good and printed.
Alright, guys, here it is. So I made it a lot smaller, and the collar slash wheel was able to work just as I wanted after a few tweaks. It's a little bit wobbly, like you can see it's a little bit not level, but it's not as bad as the last wheel. I think it might just be something with the motor itself, or I don't know. I'm gonna try and tweak a few things right now just to see if I can solve that. All right, I think I got my solution right here. This looks pretty gosh darn flat, does it not? So what I did is I took off the collar, and so there's two parts of the servo motor. There's like a full cylinder, and then there's like a flat part cylinder. So what I did is, since I made the circle just as big, I choked it down to the just cylinder part by getting rid of the spacer. So it's kept straight by the cylindrical area.
But besides that, the collar works. I think that means I'm gonna start designing other stuff. Alright, so let's delete the spacer, move the stepper motor over to this. Alright, so here's what I have so far, but one issue is, yeah, I'm gonna need a spacer here because if I want to screw it in, the motor, there's gonna have to be a spacer so the screws have a place to fit. So we're gonna redo that. Alright guys, I'm a little bit sick right now, so there's gonna be a lot of sniffling in here. So here is the design I came up with. So let's get the bar back in here and we'll get the stepper back in here. So the stepper goes into the big wheel, right? Now attached to it comes here my little hinge. I created this hinge, right? That connects to this. And we're gonna put a spring in between here, pushing this down on this just so there's some tension between the two wheels and it has better traction. Right, I need to still create the spots for the springs, but that'll be really easy and I'll just do that real quick. And this is just so it doesn't like start curving, so like it pushes it down on this as well. And then to attach, I didn't want the screw to mess with anything, so I just tucked it in like here and then hope the screw head won't pop out. I'll cover these two wheels in electrical tape so they have some traction, but I feel like that's pretty solid, and I'll just print this whole thing out and see what tweaks I need to make. Alright guys, here it is. So let's get it out, put it together, see if we have any issues. And
All right, so here it is. It actually works. I mean, it doesn't work electronically right now, but give me an idea with the springs pushing down on the wheels to give it traction. So when this wheel moves, it moves the bar. If I move it a small amount, it moves a small amount. So the traction is amazing. So what I'm gonna do, I'm gonna work on making it smaller in CAD, look a little bit nicer. But then what I gotta do is I have to make it mobile. So what I got for that, figure out a way to get this to fit without making it super chunky. Then I hook this up to this, like just a little PCB thing. Then I connect it to what I'm going to power, but one of them I split with a resistor to make it 3.3 volts for the Arduino. So I got a fit battery pack, this. That's gonna be a lot of fun. Alright, I've gotten a pretty good beta version down. This is it right here.
You know, pretty simple, just a motorized wheel, a spring pressured wheel, and then it moves the bar through this slot here, and then I basically screw it to the door and it moves the bar, and it works through Bluetooth. Basically, I text a little message to my phone and it moves this thing. I don't know how to record it because I use my phone to record and I have to text through my phone, but I guess I gotta figure that out.
Alright guys, so I got the full like disconnected setup. It's not connected to the power source at all. It's all running off these batteries. So these batteries run in series, so giving it 12 volts. Then it connects here to this pin. I think I might have just shut it off. Right? And then the power, this 12 volts runs to the motor because it can handle that. Then it comes over here, hops into these two cables, goes over here into this voltage jumper, takes the 12 volts, put it into 3.3 volts, then that runs into this. And then the 4 control pins run out of the ESP and into there. It's pretty simple. It works perfectly, but I'm having one issue. When the deadbolt comes out this way, it's perfectly fine. But when it wants to bring it back this way, it doesn't work at all. So I think that this might be offset to like where a point, like it's big enough to where it moves it that way, but then not that way. So I think I'm gonna change this so it perfectly fits the head. And then I think I might serrate it, but I'm gonna make this wheel a little bit bigger and then change the head size. So I'll make it like a point something bigger and then change the head input, see if that does it. But if that does not, I'll have to make this serrated so it can actually like gear in like a rack and pinion. So I've decided to make a change. Since I'm going to stick with just keeping the 3D print because I feel the 3D print is personally strong enough, I can turn this into a rack and pinion. In layman's terms, make the wheels gears and make the bar have teeth. So it's kind of just like a gear system that'll allow it to have perfect traction. So I'm going to learn how to do that and then do it because I don't know how to do it right now. So you'll see that. All right, guys, let me know what you think of my handiwork right here. I think for my first time making a rack and pinion, it is actually really good. I mostly followed a tutorial because like it's my first time. I'm not gonna know it off the dome. But it also taught me a lot about components because I didn't really know about that before. I'm not gonna lie. But so basically, I made this rack. And then I kind of like took dimensions from this and then made these teeth based off those dimensions. It was pretty techie stuff. I kind of just asked AI for the help if you guys want to learn on your own. The big GBT always knows the best. How am I going? You may ask, how am I going to keep the gear on here? Honestly, from what I know, this 3D print stuff just literally stays on there. I think I would be quite okay just by having it like this. If not, I'll do the same collar-ish method on this. Get a hole in here, but like for now, I don't think it's necessary. So I'm not going to do it because I think it should work. Because like this gear is only going to be working in this motion. There's going to be no stress on it to force it out. So right now I'm just going to test to see if the rack and pinion works because I'd only need to print 2 miniature parts. Then I'll start doing the big revamps on this thing. Alright guys, here's the new design. So I think this new design kind of makes the spring-loaded wheel obsolete. But here it is. This screw kind of keeps this. So it can't go any further than this. That's all the way out. And then that's all the way in. So then the motor can't mess up because it's physically stopped. But I think because there's no wiggle room in here at all and it can kind of just move, it doesn't really need the spring-loaded wheel. So I'm gonna get everything in, test it without the spring-loaded wheel, and if it works just fine, I'll just scrap it as a whole to save space. You guys are gonna just kind of have to believe me when I say it works like a charm. This is also getting quite hot. So I might create some venting so it's like not covered in straight plastic. Simpler the better, I guess. You know, just actually really simple. It's just the screw and yep. Yeah guys, all that design of that whole other thing just to come down to this. It's okay guys, we live and we learn. But this is really small, really light. I'll fix this centering right here, but yeah, I went from that big complicated ass thing to this. So now let's make it so we can fit all of this into here.
Alright guys, here's what I think is my final design. So that is just like a little bit of ventilation, this hole right here. Obviously my little rack and pinion to close and open the door, open the lid. Oh, the lid's on the other side. Open the lid. You put both battery packs right here. Should be enough space for both of them. And then here is where you fit all of the electronics. So go ahead and print it out. And I'll see you guys. Alright, here's the printed out box. Looks how we wanted it to. Sorry, it's two different colors. I ran out of black filament halfway through and switched to gray filament. So I'm just going to take the parts from this and put it in here because there's no need to reprint. And then we'll be done with our prototype. And if I want, I can make a final version, but the prototype will be just okay. So I'm going to put this together. Here's a gist of my soldering setup. I'm going to put the wires on this ESP32. Alright guys, I'm finishing up here and I figured out how to show you from my phone because I figured out how to get the BLE signal on my computer as well. So, this thing is completely independent. The only thing is the power source, which is from there, but it's the same thing as the battery. It's no big deal. This is just, it's one 11 volt connected to this, which jumps into that. That's all it is. So it can run on its own. But look, ready? I'm gonna hold it so you guys can see. I send a 0. Boom. I send a 1. Now it's a bit hot right now because I've been making it go back and forth. So probably not the best for it. Maybe I get a fan or something because this thing is really hot. But I'm sure if I'm just not using it a whole lot and it stays locked and unlocked, it'll be okay. That burns. But it's working. So I'm gonna wrap it up. Here it is. Alright. So before we conclude this video, I wanted to go over something that I didn't explain in great concept, and that was the coding. Now, since this was my first time, I obviously used AI for a lot of help, but what I have is just over here on the top left, the hashtag includes, these are all the plugins I used. So the plugin Excel Stepper is what allows my stepper motor, instead of me doing physical feet, it's like instead of me doing physical steps, right? It counts the steps itself, so it translates it into feet. So I knew that my wheel radius was 2, right? So that allowed me to plug in my wheel radius over here, right? And I could now use that as a constant, and it automatically did the math for me in this plugin, and I just typed in the distance I wanted it to travel and knew my radius, did the math, and did the correct amount of steps for that. So that really helped. You put in the steps per revolution of your stepper motor, the distance you want to travel, the radius of your stepper motor, all that. So that's what allowed me to do the math for that. It was the plugin. Then all these BLE plugins are what allowed me to have multiple open BLENs, one on my computer, one on my phone. Also, just like the constant BLE. And, I don't really know most of the coding myself because AI did do it. I'm not going to lie and say that I did all this coding because these are all plugins that I do not know. It's not coding within itself, but they're all plugins. I understand it. I went over, I learned it all. But, I'm not in the game for coding. But I know how it works, and basically what I did to fix the overheating issue was whenever it's not calling for the movement, all the pins are deactivated. All power is shut out. So if it's not, so before, what I was doing while I was getting so hot is if it wasn't moving, all the power was keeping it in place. So it was constantly coursing the 11 volts through it to keep the motor in place. But instead of that, I just changed it to where it completely turns off, which will make it be able to move left and right. But that's not the main concern because it's already going to be in the deadbolt. So the coding's pretty simple, sleek, accurate AI. It's great at everything. But, this was my project. Thank you for watching. And just because I know I shot some very shy camera angles, here's this is the cap, the vent, and in here I have the wiring. Probably should have cut the wires a little bit more. I can do that, but I would have to unsolder everything and it would be a lot of work. But here's the ESP. I left it unfastened so I could easily just update new code in case I find something that I don't like. And yeah, you see all the pins are soldered in, the ground, the hot, the 4 control pins. And then in there is the driver controller in the top right. And then to the left is the jumper. And then it connects through a hole out here to the motor, which connects to our lovely rack and pinion. But this was my project. Sorry it took so long, guys. All this stuff to understand is just a lot for first time. So I appreciate you guys watching, and I hope the video was fluid enough. Have a great day, everyone.